Welcome to another video. In this system of equivalent equations, let's see how to solve for the complex roots. But before that, so we can still get the real root of this, the trivial root. So as we have this, we have x equals to 2, and which is the real solution for x cube equals to 8, and which is trivial. And so to find the complex root for this, it's very simple. As we have x raised to power 3 minus 8 equals to 0. Then we know that from this, we have x equals to 2 is one of the solutions to this problem. Then, since we have already obtained the solutions, so we can get a factor of this, which is x minus 2. It's a factor of x cubed minus 8 equals to 0. So we can use long division method to get the other factors of this. Then we have x raised to power 3 minus 8. Then we put it in this diagram, and we have x minus 2 here. So what we are going to be doing here is, so the first x here, we'll be dividing it with this. So hereby we have x cubed divided by x equals to x squared. And we write the x at the above. Then later we are going to use this x minus 2 to multiply x squared. As when this is coming here, it comes with multiplications. And then x times x squared, that is x cubed, minus 2x raised to power of 2. Then we are going to try to eliminate something here. So by introducing negative, so these two will cancel each other. X cubed will cancel x cubed. Then we have 2x squared minus 8. As negative will affect the negative attached to 2x squared. So again, let's divide this 2x squared divided by x, that is 2x. So we're going to add plus 2x to this above. And we also multiply 2 out with x minus 2 together with 2x. So x multiplied by 2x, that is 2x squared minus 4x. So then we still introduce negative to cancel deals. Then we have 4x minus 8. So that is how we continue till we get to where we cannot divide again, or till when we get 0. So if it requires. So we still got plus 4 here. So I'm going to multiply 2 out 4 together with x minus 2. Hereby we have 4x minus 8, and the entire of this one becomes 0. So as soon as we got 0, we are going to stop, because any other things will keep becoming 0. As x minus 2 is divisor, x squared plus 2x plus 4 is our quotient, and x cubed minus a, we call it dividend. While the last one, which we got as 0, is known as our remainder. So if the remainder equals to 0, we are going to apply this formula. Or before the remainder equals to 0, so let's consider this standard formula for when we are applying the long division method of polynomial. So we have dividend over divisor equals to quotient plus remainder divided by divisor. So for this one, we know that the quotient we got is x raised to power 2 plus 2x plus 4. So plus again, we have the remainder to be equals to 0, and here is x minus 2, which is the divisor. So what our dividend is x raised to power of 3 minus 8, while divisor is x minus 2. So as this one becomes 0, then we have x cubed minus 8 equals to bracket of x squared plus 2x plus 4. And we are going to multiply this with x minus 2, which means that the entire of this at the right hand side are the factors of this. So then we want to obtain the complex root of this. So we are going to consider only x squared plus 2x plus 4, which is equals to 0. And from here, we know that if you consider from the discriminant, which is equals to b squared minus 4ac, and we know that from this quadratic equation, a equals to 1, b equals to 2, and c equals to 4. So by substituting this thing in this discriminant formula, we are going to have d equals to 2 square minus 4 bracket 1 bracket 4. So and this becomes 4 minus 16, and this is equals to minus 12. So minus 12 less than 0, so which means that we are going to have the root which is imaginary and complex. I mean the discriminant here is imaginary and complex. So if it is imaginary and complex, so we are going to get the complex root for this as from the quadratic formula, which is x equals to minus b plus or minus the square root of d, so which is the discriminant divided by 2a. On getting this, we are going to substitute the values, which is minus 2 plus or minus yd is the root of minus 12 divided by 2. So you know that this root of minus 12 is a complex root, and which can still become the root of 12i. So by having this minus 2 plus or minus, we are going to have this is the root of 12i divided by 2. And this root 12 itself, so we can break it down into minus 2 plus or minus 2 root 3i divided by 2. So then if I try to divide 2 by 2, or let's say I factorize out 2, so we're going to have minus 1 plus or minus the root of 3i, which this one is the complex root for the cubic equation we are given above. And this is how to solve this. But if you have another way of doing this, you can drop it in the comment box. And don't forget to subscribe to this channel and turn on the notification bell. Never stop learning.